We throw the term software engineering around all the time, but have you ever really stopped to think about where it came from? It wasn't born in some Silicon Valley boardroom. Nope. It was forged in the fire of the Apollo program by a brilliant woman who knew her team's work deserved respect. This is her story. And this quote from the woman herself, Margaret Hamilton, just says it all. It perfectly captures the massive challenge she was up against. I mean, can you imagine? Your job is to write the code that lands human beings on the moon, and the entire field you work in is treated like an afterthought. So, to really get this, we've got to go back in time. We're talking the early days of the space race. Back then, hardware was king. Big, tangible rockets and machines. Software? Well, that was a whole different story. Yeah, this really gets to the heart of the problem. Software wasn't seen as a science. It was more like an art, a mysterious black box. Other engineers, the real engineers, would literally just throw their requirements over the wall and expect the software to kind of magically appear. It was not considered a serious discipline, which is, a terrifying thought when human lives are at stake. And this is where Margaret Hamilton steps in. She was the director of the software engineering division at MIT, and she knew this perception had to change, and fast. The Apollo mission demanded a level of precision and reliability that the so-called art of programming just couldn't guarantee. And this was the key question she asked. She looked over at the hardware engineers and the aerospace engineers with all their rigorous, systematic processes. Then she looked at her own team, building these incredibly complex life-or-death systems, and realized they needed a way to legitimize their work. They needed a name that commanded the same respect. So she came up with one: software engineering. She intentionally chose the word engineering to make a very powerful point. She was saying that building software wasn't just typing code. It was a true engineering discipline that needed to be just as systematic and just as disciplined. And at the time, people actually kind of laughed at her for it, calling them radical ideas. But here's the thing. This was never just about finding a fancy title. It was about earning respect through sheer excellence. As Hamilton put it, that breakthrough moment came not because the hardware guru suddenly liked the term, but because her team had proven through their incredibly meticulous work that they were engineers in every sense of the word. And they absolutely had to be. Let's really talk about the stakes here. They were building what was called man-rated software. That's a fancy way of saying if your code has a bug, people die. There are no do-overs. That's it. One chance to get it right. The software for the Apollo guidance computer had to work flawlessly the very first time it was ever used for real. You can't exactly do a beta test on a trip to the moon. So Hamilton and her team had to invent entirely new ways to make software that was rock solid. And what they came up with was absolutely genius. They built a system where every single job the computer had to do was given a unique priority. So if something unexpected happened, the system could instantly detect it, figure out what was most critical, like, say, landing the spaceship, and then kill and recompute everything else that wasn't as important. It was a revolutionary idea. Which brings us to July 20th, 1969. The final exam for all of their software engineering. The Eagle is making its final descent to the surface of the moon. The entire planet is watching. And then alarms start going off. I mean, look at this timeline. It shows just how razor-thin the margins were. With just minutes left before they touch down, these program alarms, a 12:01 and then a 12:02, start flashing in the cockpit. Down in mission control, you can just imagine, heart stopped. This was the nightmare scenario. These alarms meant one thing: the computer was overloaded. A radar system that wasn't even supposed to be on was flooding it with useless data, eating up precious processing power at the most critical moment of the mission. The astronauts and mission control had a split second to make a call: abort the landing or trust the software. And this is it, the magic moment. The software that Margaret Hamilton and her team had engineered did exactly what it was built to do. It recognized the overload, it threw out all the low-priority junk from the radar, and it focused every single cycle of its processing power on the only job that mattered: landing the lunar module. It didn't just work, it saved the mission. So the landing was a historic success. But for Margaret Hamilton, the lessons from those harrowing final minutes were just the beginning. That experience completely reshaped her entire philosophy on how software should be built, a philosophy that's more relevant now than ever.
She realized that the way most people build software was what she called a curative paradigm. Basically, you build it, and then you spend forever testing it to find and fix everything you got wrong. But she argued for a preventative paradigm. The goal here is to design your systems and your languages so intelligently that entire categories of errors are impossible to make in the first place. It's all about doing things right from the start.
And in the end, that's the legacy Margaret Hamilton gave us. It's not just a job title, it's a whole way of thinking. And it leaves us with a really important question for today. In a world that runs on code, are we still just playing whack-a-mole with bugs, or are we actually engineering our software to be right from the very beginning?